Okay, real quick, we're just going to make sure everybody understands how to do matrix multiplication, which is also called finding the dot product. First thing you need to know is that matrix multiplication is not always commutative. That means you can't switch the two matrices and get the same answer like you can with real number multiplication. Also, the two matrices aren't going to have the same order unless they are square, because the first matrix, however many columns that has, that's how many rows the second matrix has to have. So here, the first matrix is a 2 by 3 matrix. It has 2 rows and 3 columns. The second one has 3 rows and 2 columns. And so in order to be able to multiply two matrices using the dot product, these middle two numbers have to be the same. The number of columns in the first matrix has to be the same as the number of rows in the second matrix. So the middle numbers have to be the same. And then when you get your resulting matrix, it's going to have the order of the outside numbers 2 by 2. So you can see that this right here, the answer, is a 2 by 2 matrix, 2 rows and 2 columns. So that's always going to be how it works. If you want to multiply two matrices, the middle numbers have to be the same, and your answer will be of the order of the outside numbers. So let's go ahead and look at that process. So finding the dot product. So the first thing you're going to do is you're going to start with the first row and the first column, first row of your first matrix and the first column of your second matrix. And you're just going to go across the first row and down the first column, and you're going to multiply the numbers like this, and you're going to add that all up. So you're going to say 7 times 1 plus 9 times 2 plus 11 times 3, and that's 7 plus 18 plus 33, and that is 58, and that will go in your first row, first column of your answer. Next, you would do that first row again, but now you're going to go down the second column of the second matrix. So you're going to go across the first row of your first matrix, and you're going to go down the second column of your second matrix. And however many columns that matrix has, you just keep going across and down, across and down, across and down, and adding them up until you're done with all the columns in the second matrix. But this one only has 2, so this will be the last one we have to do. So going across and down, so we're bringing those over there, and we're multiplying them together. So we'll have 8 times 1 plus 10 times 2 plus 12 times 3, and that's 8 plus 20 plus 36, and that's 44, and that's what goes in the first row, second column. So we're done with the first row. We've done the first row in both columns of the second matrix. Now we need to go do the second row of our matrix across and down to all the columns of the second matrix. So we're going to go row 2 times column 1. So row 2, 4, 5, 6 times column 1, 7, 9, 11. Bring those numbers over. Oops. And so you've got 7 times 4 plus 9 times 5 plus 11 times 6 is 28 plus 45 plus 66, which is 139, and that will go in your second row, first column. All right, and then last of all, you're going to go across that second row in the first matrix again, and you are going to go down the second column of the second matrix. So 4, 5, 6, and you're going to do all that multiplication again. So you've got your 4, your 5, and your 6, and you're going to multiply. So 8 times 4 plus 10 times 5 plus 12 times 6 is 32 plus 50 plus 72. And when you add all that up, you get 154, and that goes in your second row, second column, and that's your answer. So that is how you do matrix multiplication or finding the dot product. So let's look at another example. All right, this one's pretty simple. We know that this is a 3 by 3 matrix over here, and this one is a 3 by 1 matrix. And so you can see that the two middle numbers are the same, and so you know that this is possible You can multiply these. Okay, so you know that your answer is going to be a 3 by 1 matrix. So it's going to be 3 rows and 1 column, just like the second matrix there. Okay, so we're just going to go across and down. We're going to do first row of the first matrix and first column, there's only one, of the second matrix. So we're going to have 9 times -1, -9 times -1, plus 2 times 5, plus 3 times 0. And that's going to be 9 plus 10, which is 19. So that will be our first element in the resulting matrix. All right, now we're going to go across the second row, first column, because there's only one. Okay, so second row starts with a -1, so we've got -1 times -1 plus the 5 in the second column of the first matrix, second row, 5 times the 5 in the second matrix. And then the last thing is always going to be 0 because it's a 0. So 4 times 0 is 0. Okay, so you've got 1 plus 25 is 26. So that's going to be your second number. And now you're going to do your third row across and down that column. So you've got 0 times -1. And then you've got 1 times 5. And then you're adding 7 times 0. And so that's just 5. And that's going to go right there. So that is your answer. Okay, this is a business application of matrices, example 8. A company owns 2 coffee shops. The number of donuts, coffee cakes, hot drinks, and cold drinks sold for each shop is given in matrix Q. The price per item is given in matrix P. Find the product QP and interpret the result. Okay, so you have this first matrix, which is showing you the 2 rows are the shops. They have 2 shops, shop 1 and shop 2. And the rows are telling you how many donuts, how many coffee cakes, how many hot drinks, and how many cold drinks are sold at each shop per day. So the second matrix, P, is telling you the cost of each of those things. Donuts are 40 cents, coffee cakes are $2.50, hot drinks $3.50, cold drinks $1.50. So we are going to multiply these 2 matrices and then say, what does that tell us? And it's fairly simple, but we'll do it anyway. All right, so this is a 2 by 4 matrix, and this is a 4 by 1 matrix, so we know that they can be multiplied because the middle numbers are the same. And we know that our answer is going to be a 2 by 1 matrix because those are the outside numbers. So that means 2 rows and 1 column. So it's just going to look like that. So we're going to go ahead and do that multiplication, that dot product. So we're going to go across the first row and down the column. So we're going to have 162 times 0.4 plus 34 times 250 plus 120 times 350 plus 44 times 150. All right, and if you punch all that into your calculator, at least if I did it right, you should get 635.80. So that is the first element in this answer, 635.80. And now we're going to go across the second row and down the column again. So we'll have 186 times 40 cents plus 50 times 250 plus 145 times 350 plus 62 times 150. And if you punch all that into your calculator, that is $799.90. and that goes right here. And so when they ask you to interpret the result, that's just telling you how much each store makes per day. So this is the amount of money. The first number is telling us the amount of money in that shop 1 earned that day. And this is telling you the amount of money that shop 2 made that day. Okay, now we have example 9. Consider the triangle in figure 6.6. The vertices of the triangle can be represented in a matrix, where the first row represents the x-coordinates and the second row represents the y-coordinates. Use addition of matrices to shift the triangle 3 units to the left and 2 units up. This is also a fairly trivial thing they're asking you to do, but they're just trying to give you simple applications. So you want to shift the triangle 3 units to the left and 2 units up. To do that, you would want to subtract 3 units from all of the x coordinates because that would move the triangle to the left. And then you would want to add 2 units to each y coordinate so that would raise the triangle up. And this is not the same thing as transforming an equation to make the graph move. This is just, we're looking at the points themselves, and we're just trying to change those points so that the triangle will be in a different place. So again, we're wanting it to move it 3 units to the left, which means we need to subtract 3 from every x coordinate. And then we want to move it up 2 units, so we're going to add 2 to every y coordinate. So that's all we need to do. So we just need to add the matrix. So we've got the matrix here, which has 1, 3, 7, 0, 3, 0. That first row is all of the x coordinates, and the second row is all of the y coordinates. And so we want to add a matrix that will subtract 3 from all the x coordinates and add 2 to all the y coordinates. So we just would add this matrix, 3, 3, 3, negative 3, negative 3, negative 3, and then 2, 2, 2, because that's exactly what I just said. So that will give you the matrix negative 2, 0, 4, and then 0 plus 2 is 2, and 3 plus 2 is 5, 0 plus 2 is 2. So these are the new points that you would have. You'd have negative 2, 2, and you would have 0, 5. Oops, what happened to my negative 2? 2 disappeared. And then you would have 4, 2, which is here. So this would be your new triangle. And you can see that it has been moved 3 to the left and 2 up. All right, so part B says find the product negative 1, 0, 0, 1 dot A and determine the effect on the graph. So we're going to take the dot product of this matrix negative 1, 0, 0, 1 and our matrix that has the points in the triangle. So I'm going to do that dot product, and let me just find a place to do that. We'll do it right here. So you've got negative 1, 0, 0, 1, and you're going to multiply that by 1, 3, 7, 0, 3, 0. And so this is a 2 by 2 matrix, and this is a 2 by 3 matrix. So you're going to end up with a 2 by 3 matrix. All right, and if you start at the first row and go down the first column, you're going to have negative 1 times 1, which is negative 1, and then 0 times 0, which is just 0. So negative 1 plus 0 is negative 1. And then you're going to go across the first row again, and you're going to go down the second column. So negative 1 times 3 is negative 3, plus 0 times 3 is 0. So negative 3 for your middle number here. Now you're going to go across that first row again and go down the third column of the second matrix. So you'll have negative 1 times 7, which is negative 7, plus 0 times 0, which is 0. So negative 7 right there. All right, so we did the first row, we across all the columns, and now we need to do the second row. So the second row is 0, 1. We're going to go across and down, so 0, 1, across and down 1, 0. So 0 times 1 is 0. 1 times 0 is 0. If you add 0 and 0, you get 0. And then we're going to take that second row and go down the second column. 0 times 3 is 0. Plus 1 times 3 is 3. So we have 3. All right, we go across again. 0, 1. Down the third column, 7, 0. So 0 times 7 is 0. 1 times 0 is 0. So that's just 0. All right, so our new triangle has these coordinates, -1, 0, -3, 3, and -7, 0. So -1, 0 is right here. -3, 3 is right here. And -7, 0 is way over here. So we would just draw this like this. And you can't really tell now because, well, it's far away. But the original triangle was right here. We don't have the 7, but anyway, the original triangle was here. So the question is, what did we just do by multiplying it by this matrix? And we flipped it across the y-axis. So we flipped it around over the y-axis, or reflected it across the y-axis by multiplying that matrix by that matrix. And then if you look at part C, you're going to multiply the coordinate matrix for the points of the original triangle. You're going to multiply 1, 0, and 0, -1 times that matrix. So we've got 1, 0, 0, -1. We're multiplying that, taking the dot product of that, and 1, 3, 7, 0, 3, 0. And when we do that, we are going to get exactly what we got before, which is a 2 by 3 matrix. So I'm going to go across the first row, 1, 0, and down the first column. So 1 times 1 is 1, 0 times 0 is 0. So 1 plus 0 is just 1. I'm going to go across the first row and down the second column. So 1 times 3 is 3. 0 times 3 is 0, so 3 plus 0 is just 3. I'm going to go across the first row and down the third column now. So 1, 0, 7, 0. So 1 times 7 is 7. 0 times 0 is 0. 7 plus 0 is just 7. And then I'm going to go across the bottom row now of the first matrix. 0, -1, going down the first column of the second matrix. So 0 times 1 is 0. -1 times 0 is 0. So that's just 0 plus 0, which is 0. And then the second column now, I'm going to go down the second column of the second matrix. 0 times 3 is 0, and -1 times 3 is -3. So 0 plus -3 is -3. And then I'm going to do the very last column, across the bottom row of the first matrix, down the third column. So 0 times 7 is 0, and -1 times 0 is 0. So I just have 0. So my new matrix this time is 1, 3, 7, 0, -3, 0. So those are the points, 1, 0, 3, -3, and 7, 0. So that triangle looks like this. And in this case, you can see from the original triangle, we have flipped it over the x-axis. So that first matrix made it flip across the y-axis, and the second matrix made it flip across the x-axis.